Gentlemen, Paul Ratcliffe, thank you.
Thanks, mate. G'day guys. Look, I'm sorry for being late. There was a motorcycle accident on Motorvale Road. It took me 2 hours to get here. I want to basically go through some of the... Is this microphone, is it working? All right. I want to go through some slides tonight. I'm going to touch on bathroom, balcony, planter boxes and roofs. I'm going to talk about what's available in terms of reference material. I'm going to mainly do this through pictorial presentation of things that I've seen while I'm out there. When I put a photo up there, I'll tell you what I can see and what you guys can do to make sure that it doesn't happen to you. Basically, in bathroom waterproofing, in terms of reference material that you've got available to you out in the marketplace at the moment, you've got AS 3740 2004, you've got the BCA provisions 3.8.1, you've got the Blue Book, which you've got in front of you, and you've got manufacturer's requirements. In terms of licensing of waterproofing at the moment, with licensing for bathrooms, it's a 4-day course. If you've done 2 years experience in waterproofing, you can go out there and grab a licence and go to a builder and waterproof a bathroom, and that waterproofing has got to last for at least 7 years. Although there is litigation that's happening now that runs out to about 10 years. So in other words, if you're a builder sitting in this room, when you waterproof a bathroom, the waterproofing has got to last at least 7 to 10 years. I had a phone call today, this is no word of a lie, from a builder, marble bathroom, waterproofed it. It's 6 years and 9 months down the track, and he's got a leak. They pulled up a piece of the marble in the bathroom. There's a split at the wall floor junction. The owner is an engineer. The owner wants all of the bathroom pulled up and the waterproofing rectified. So when you waterproof a bathroom, when you stand there and say to the tiler it's ready to tile, you need to be comfortable that what you've done is going to last 7 to 10 years, because the reality is it's your ass on the line for that period of time. In terms of the BCA, it references AS 3740, and AS 3740 is the minimum standard of waterproofing in the building industry at the moment, the minimum standard. So you've got your $40,000 bathroom. Are you going to waterproof to the minimum standard, or are you going to waterproof to your standard, manufacturer's standard, or what? In terms of a bloke like me, when I come along to have a go at you because you haven't waterproofed properly, the documents I've got is the BCA, AS 3740 and manufacturer's requirements, right? So I'm going to go you hard on AS 3740. In terms of AS 3740, the things that I don't like in AS 3740 is that in terms of waterproofing a bathroom, you only have to do water-resistant construction on the walls in the shower recess. What that means is tiles over render, tiles over FC sheet, and that's it, you comply. Other issues that I don't like is that if you've got an enclosed shower only, now an enclosed shower is a shower that's got a shower screen, in other words a bottom rail, you only have to waterproof the shower itself if you're on concrete and fibre cement sheet floors. If you've got particle board flooring, you've got to do the whole floor, which in my opinion is a joke. An unenclosed shower screen is a shower screen that has just got glass that runs down to the floor that has silicone. Now in terms of that bathroom, you've got to waterproof concrete and FC sheet flooring out to a radius of 1.5 metres and particle board flooring the same. So you can see these are the minimum standards in AS 3740. In terms of bath rims and basins, the AS 3740 only requires you to put a silicone bead at the wall, at the junction of the wall tile and the bath rim. So if I came along, you've waterproofed your bathroom and you haven't painted the walls behind the basin or the bath with waterproofing, you can quite rightly stand there and say, I've waterproofed to AS 3740, that's all I need to do. Whether you'll get insurance with these guys is probably another thing, because you will probably eventually have a claim. As far as AS3740, it doesn't matter if you've got a shower over the bath. You only need to put a silicon joint at the wall floor junction. You can run the door jamb and architrave down into the tile bed as long as you waterproof the front of it. They don't say anything about MDF and the effects of moisture on MDF in bathrooms. There's no requirement to recess drainage flanges into the bathroom. If you guys aren't doing it, it's a common defect. If you guys, if you guys are waterproofing and you're using an acrylic membrane system and you're not recessing your bathrooms, you'll find that manufacturers don't recommend water to pond on acrylic membrane systems because what it does, acrylic membrane systems are porous. If you want to test that out, get your acrylic membrane, pour it onto a bit of plastic, let it cure, let it dry out, and then make a little bag out of it, fill it full of water and see what happens. You'll probably find water dripping through it in about a day, and that's the reality of it. Acrylic membranes are porous. You don't have to waterproof under baths and there's no requirement to create fall-in substrates. Manufacturers also have requirements, and when you guys stand there and you've got a litigation matter against you, you're going to have the manufacturer standing alongside you trying to get out of the claim. And your backup's going to be your warranty from your waterproofer for your labour and your warranty from the waterproofer from your manufacturer, right? They're your two parts to your warranty. In terms of a one-stop shop, there's not too many manufacturers out there that will give you a labour and material warranty, but you should be checking on that with your warranties with your waterproofer. The sort of things that are common is that acrylic membranes require primers. Quite often when I go to a job, you peel the acrylic membrane off the wall, no primer behind. All membrane manufacturers require the surface to be dust-free, and in actual fact AS3740 also says that the surface must be smooth, dry and free of undulations, and there can be no latents or debris or dust. So if you have that situation under a membrane, manufacturer is going to do a runner. Manufacturers of acrylic membranes generally say that you can't pond water on their membrane because they won't warrant it, which is interesting for shower recesses. And polyurethane membranes require moisture content of not greater than 15%. These are some of the snaps that I've got on bathrooms, and I'll just sort of turn around and face the screen if that's all right. You can see here, this is a backing rod underneath a shower screen. The situation here was that water was leaking straight out from underneath the shower screen into the main bath area, and then it was leaking out of the door of the wet area. AS3740 requires the water stop angle to go up to and finish 5 mil above the surface of the tiles. So in that situation, you guys, when you're setting out to shower your water stops, you need to take into consideration the height of the tiles and obviously the height of the shower bottom screen. What I normally do is use a PVC angle, and if you put like a 50 mil angle in, you can always come through and trim it off later on to suit the height of the shower recess. I'd recommend that you guys consider doing that. This is a common detail that's crept into the industry. It's a flange that's been placed around the drainage outlet, and it doesn't comply with AS3740 because there's no slots cut into the side of it. And in this instance, it was preventing substrate water finding its way to the floor waste. Similarly, no slots cut into this. If you get this type of flange, if you're intending on installing this type of flange, just grab a drill some holes into the side of it so that the water can find its way to the drainage outlet. This is the same bathroom as previously shown, and you can see this is the tile angle at the door. Quite often I'll arrive to a site to find that the carpet in the hallway outside the door is water damaged, and the builder will say, well mate, I left the waterproofing up to the waterproofer, the waterproofer will say, well mate, I didn't know what height to set the angle at the door because I'm not the tiler. And the tiler turns around and says, well, I'm not the waterproofer and it's not my responsibility to do the waterproofing. I just stick the tile in. So everyone's going, not me, it was him. Ultimately, it's the builder that's responsible. You should be able to calculate the height of the water stop at the door to the wet area. And the angle that goes in there should not be less than sort of 45, 50 mil. If you consider, it's a very simple calculation. The way to do it is to start at the floor waist in the bathroom. Have I got a whiteboard here? No. If you start at the floor waist in the bathroom, work your minimum tile bed thickness at the floor waist will be, say, what, 25, 30 mil? If you've got a metre from the floor waist in the centre of the bath to the door, 1 in 100 fall, that's 10 mil. If you've got 30 mil tile bed at the floor waist, plus another 10 in fall, that's 40 mil, plus the thickness of the tile at the door, you're talking at least, you know, another 10 mil, so a 50 mil angle. So if you're using a polyurethane membrane unbonded screed, you know, it's going to sound pretty drummy at the floor waist if your tile bed thickness is less than 30 mil. And in fact, I've seen jobs where the tiles pop off because the tile bed gets down to 15 mil, and you know, you can't do that. So you need to think about these things when you're setting up your water stop at the door to the bathroom. Alternative detail, this is in the blue book, is to have the water stop finishing like this. You can put a threshold tile or piece of timber across the door to comply with the BCA. That's not a bad detail. That's being adopted by Multiplex on one of their inner city jobs. We sort of hijacked that idea from them. When you lay your waterproofing, you should get down on your hands and knees with a torch and inspect it if you're a builder and you're warranting it for 7 years. What you look for is these type of things. They're tiny little pinholes that have formed in the surface of the membrane. Depending on the type of membrane system, this was a cementitious acrylic. With cementitious acrylic membranes, it's really important to mix it up really well. What you get is you get a drum of liquid and you get a drum of basically cement, and they pour the bag of cement into the membrane system and they get a drill and they mix it up. What happens is you can get tiny little balls of cement that haven't been mixed through the membrane system, and what happens is once the membrane cures, they pop and you end up with these pinholes. If that were a polyurethane, and there's some photos further on, I'll show you what happens with that membrane system. This is a membrane I went to look at that was obviously pulled up. You can see the backing rod here, and the membrane has failed along this joint. What is wrong with that? There should be a bond breaker tape across the backing rod to isolate the membrane from contact with the backing rod. You can see that it runs into the corner finishes there, and then they've gone to a fillet joint in the back. I don't like backing rods. I've seen so many failures with backing rods. I prefer to see a fillet joint. Difference between a bond breaker and a fillet joint, I'll get to in a minute. AS 3740 recognises bond breakers and fillets as a really important part of a membrane system. If you ask me what is one of the most critical things in membrane installation, it would be bond breakers and fillets. They're located at the wall floor junction, and that's where your movement occurs. If you're on a job and you're setting a bathroom up or a balcony or whatever that's going to be waterproofed, a planter box, movement is going to be your killer. So if I'm going into a bathroom that's a blue board, a timber floor, I'll literally go around that bathroom and kick the base of the walls with my boot, kick the doors, kick the floor wastes, go and put the boot into everything just to see how much movement you've got. Jump up and down on the floor waste and see how much vertical movement you've got. Because when you consider, say, an acrylic membrane's got an elongation to break of, say, 300%, That's 0.3 of a mil of movement and the membrane splits. You know what I mean? It's not bloody much. Movement's the big killer. And when you're selecting membrane systems, you need to take that into consideration. You need to look at what you're expecting the membrane to be able to do. If I've got, for example, a timber deck as opposed to a concrete deck, I'll treat those two different membrane situations totally different. I want a more elastic membrane system on the deck that's timber framed than I would with a concrete frame deck. And in the blue book and in the red book on the balcony book, you'll find that there's membrane selection charts that will assist you with those selections. But AS 3740 says that some in situ membranes are not considered sufficiently flexible to stretch without tearing or flexible enough to bend without breaking when subject to joint movement. More rigid membranes are better suited for use with backing rod or bond breaker tape, and bond breakers shall be the type compatible with the flexibility class of the membrane. And then they give you this table, which is extremely scary and I don't think really reflects what's happening in the industry. To bridge joints of 5 mil. So say you're expecting 5 millimetres of movement in a joint at a wall floor joint, right? And you guys are probably thinking, bloody 5 mil of movement? When am I going to get 5 mil of movement? Let's just jump down to this table down the bottom here, and this is straight out of AS 1684.2, which is the light timber framing code. Bottom plates that are 45 mil, unseasoned softwood, you're going to get 3.6 mil of shrinkage. If you've got a 200 mil floor joist in unseasoned softwood, you're going to get 8 mil. And then you go to unseasoned hardwood and you've got 7.2 to 16 mil. And I've seen membranes, I've seen a timber frame first floor bathroom that's had 8 mil of shrinkage evident at the skirting. And the interesting thing was that the membrane hadn't failed. And the reason for that was that the builder recognised that he was going to get joist shrinkage and he installed a PVC membrane system because he was anticipating it. So when you go in there, if there's any waterproofers in this room, if you go in there and you're looking at waterproofing a bathroom, not only are you looking at the surface of the substrate and the movement, but also what's underneath it. You know, LVLs are fantastic. You know, you really want to be looking at those in your bathrooms if you can do it. Just anything you can do to reduce movement and shrinkage is really important to membranes. So going back to AS 3740, if you've got 5 mil of shrinkage, if you're putting a fiberglass reinforced or a fiberglass membrane system in, a class 1 membrane, and I'll scare you even further, if you put acrylic, so if you have an acrylic membrane, put fiberglass in it, you reduce it to a class 1 membrane, you need to have a backing rod that's 75 millimetres high. You think about that. How do you tile over that in a bathroom when you've got a 35 mil tile bed? It's just impossible. Class 2 acrylic membrane, 35 mil, and a class 3 polyurethane membrane, 12 mil. So there's some scary numbers that would come back to bite you if I had to write a litigation report on your failed bathroom. So looking at movement and, you know, if you've got 3.6 mil, obviously, you know, that 75 mil might be 50 mil and that 35 mil might be 25. Personally, I wouldn't go under 12 mil for a fillet joint in a polyurethane membrane. And most of the manufacturers of polyurethane membranes recommend minimum 8 mil. Me, I go 15 because I reckon that's where you're going to have a failure. Really give it lots of sealant. This is a class 1 bond breaker. This details straight out of AS 3740. You can see the tape that's supposed to go underneath the backing rod. The idea of this is that it debonds the membrane across this joint and allows this to go down, and the membrane basically straightens out. The problem with this detail, in my experience, is that it will split here and up here where the tape ends. It'll literally pull off the tape. Don't recommend you use that membrane system or that method of doing bond breakers in your bathrooms. Fraught with danger. Similarly, this detail I don't recommend because in my experience it will fail probably at this joint there and that joint there. The reason for that is that the membrane at that point is literally only 1.2 millimetres thick. And what's going to happen is this is going to go down and it's going to stretch that membrane at that point and it'll split there. So there are your bond breakers. This is this is more of a fillet joint where you've got flexible sealant pushed into this corner and the membrane runs up and over it. It's still important that you don't get a bond between the membrane and the sealant that you put in the corner, and that's the idea of the bond breaker. This is for acrylic systems, and that's why they recommend the use of silicone in that corner and the acrylic if you're using an acrylic system. Because if you've ever put acrylic, say you've put silicone on your windows to put your windows in, and then you come along and you paint over it with acrylic paint, doesn't stick. Exactly the same with an acrylic, with a membrane system. A fillet joint, on the other hand, with a polyurethane, you would use compatible sealant. So you'd use a polyurethane sealant followed by a polyurethane membrane. And in the blue book, there are charts in there that give you what's compatible with what membrane system for fillet joints, and you should have a look at those. Balcony waterproofing. Well, balconies, planter boxes and flat roofs, mate, you're on your own as far as AS37, as far as the Australian standards, the BCA. Well, BCA, it's basically performance requirements. The only thing you've got out there to protect you builders at the moment is manufacturers' requirements, because there's no Australian standard that says you've got to do anything for a planter box, a balcony, a roof, other than water can't find its way into the dwelling, cause undue damage and unhealthy conditions. Apart from that, it's the law of the jungle for you guys. So it's really unfortunate. There's a draft Australian standard out at the moment that hasn't been gazetted. So it's why we're seeing so many failures in balconies, planter boxes and flat roofs. If you want to protect yourself a little bit, my recommendation would be grab a copy of the Red Book from the MBA. That's got some really good details in there. We're working on a planter box book at the moment. I would suggest that you, if you get stuck, get in touch with the MBA, come up with some standard details. And by the way, I'm not here just to push the book. It's just that there's nothing else out there. If you do get stuck, go and have a talk to Alan, and other consultants are out there to help you. But really, as far as standards are concerned, there is nothing. These are some photos of failures that I've seen with balconies. Poor surface preparation, it's a cementitious acrylic membrane, and poor application over the top of a sort of a hole that was in the blowhole in the concrete. Not a good detail, that'll leak there. Membrane too thin. Once again, cementitious acrylic membrane system. You can see that that's the sealant at the wall floor junction coming through. Just, I hope you don't mind, but as I go through these slides, things come into my head and I'll just sort of go off the topic a little bit. They're a good thing to do with membrane systems, particularly polyurethanes, is if you go to a manufacturer, some of the manufacturers are actually producing their membranes in different colours. So if you can get, say, 2 different colours for your polyurethane membrane, you might put, say, a black coating down first and then a yellow coating down over the top. And the benefit of that is it gives you a gauge for film thickness. Because in terms of gauging film thickness is really important for movement. If you think of an elastic band, a really thin elastic band, if you stretch it will break easily. A thick elastic band is going to move more and be able to withstand differential movement. So film thickness and getting a good coating on there is really important. So different colour membrane systems works well. This is what happens with polyurethane membranes where you get pinholing. This is a job that I was project managing in Manly. All of those little pinholes on the surface of this membrane popped, and resulted in little holes in the membrane like this. That occurs because of two possible reasons. With polyurethane membranes, they don't like moisture. So if you're putting a polyurethane membrane down on a balcony deck, let's just use a balcony deck, they're usually not UV stable. If you're applying that membrane, the surface of the existing membrane needs to be completely dry. On this job, what happened was the waterproofers got there at 7 o'clock in the morning. There was a heavy dew on the surface of the membrane. There was a big roof area, big sort of roof balcony area. They didn't allow the sun to dry the membrane out, and they just got the product on. And by 9:30, the whole of that membrane had delaminated and popped like this. And I've got photos of what happens. This is another one that's currently in litigation. Same situation, but they didn't come back and fix it. This was leaking all over the place, and the cost of repair was about $800,000. So in terms of what you guys need to do is you need to take responsibility with your waterproofer and just look at the work method statements that are in the back of the red book from the MBA. That'll tell you exactly step by step, and in the blue book of what should be done in the laying process. And this is what happens when you come back and pull it off later on when there's been moisture on the surface of the membrane and it hasn't bonded. Another reason for that as well is with polyurethane membranes, there's a window of 72 hours upon which you can put the next coating. Not a lot of people know that, not a lot of waterproofers know that. So what happens is they'll come put the first coat, come 4 or 5 days later, put the next coat. Literally the two coats won't bond. It's like getting Glad wrap and putting it on glass. It doesn't, the two coats won't bond. So effectively, you'll be able to come along, scratch it with your fingernail and pull the second coat straight off. That's another photo of another job where the same situation applied. Balcony posts are always a problem in terms of detailing. You can see here, this membrane had failed, no fillets around here, lots of movement would occur at this joint, and the tiles would finish above this level, above the level of the membrane, which would cause this to delaminate. This was a bitumen membrane. How do I know that? You can see the bitumen staining coming up through the membrane, and it's also been exposed to too much UV. With polyurethane membranes, the longest I'd like to leave them out in the sun before they get coated would probably be maybe 2 weeks, 3 weeks at the most. You're really pushing it. They start to chalk over on the surface. In the red book from the MBA, we've got these details which show you the membrane coming up and finishing above the surface level of the tiles. A tip. If someone wants you to do something, say an architect comes along and says, I don't want to see the membrane above the surface level of the tiles on the balcony, or I don't want to see the membrane coming above the tiles around the balcony posts because I don't want to have a shoe there, don't do it. Don't build it. Just don't build it. It's not worth it. Because what will happen is it'll fail because you know it's going to fail and you build it anyway. It'll end up in the tribunal and the member will sit there and say, Mr. Builder, are you a professional builder? Yes. Have you gone and done a building course? Yes. Did you know this would fail at the time of building it? You're going to say, yes, but. No, you won't even get the but out. But you built it anyway? Yes. And you know how much this is going to cost to fix? Yes. And you build it anyway? Yes. You won't get anywhere with a member of the tribunal. They'll just say, I'm sorry, too bad, so sad. You're a professional builder, you're supposed to know these things and you shouldn't have built it. There is a clause, clause 18F of the Home Building Act, which says if you're aware that a detail won't work, you have to put it in writing and put it to the architect or the client and say, I'm not happy with this detail, it's going to fail. That clause doesn't cover you in my experience in litigation. My advice to you is to say, look, I'm sorry, but I'm not going to build it. I'm going to walk away from this. Here's your credit for the work. Don't do it. I'd rather you went in to fight about not doing the work than go in to fight and argue that you did the work and poor you, you know, because it's not a good argument. I'd rather go in and fight contractually that that the credit that you're offering is not enough, or fight contractually that you're doing something that you're in breach of the contract, and try and fight for the fact that there's now $200 or $300 or $600,000 worth of repairs, and you knew about it and you still did it. So don't do it. Just don't do it. And I would say that your insurers would probably stand right behind you in that situation where you may have potential litigation because you won't do something because you know it's wrong. So, if in doubt, put your hand up and ask for help. You know, there's organisations like the HIA, the NBA, and there's your insurer there as well, all stand there saying, you know, if you're a good builder, I'll help you. But when it goes the other way and you turn out, you know, you've got a $600,000 claim, no one wants to know you except lawyers and building consultants like me, who will ask for a $5,000 deposit before I even do anything. So this is a common detail that's crept into the industry where a balcony membrane system finishes below the surface level of the tiles. That is not a recommended building practice. You'll find that the manufacturers of the waterproofing will come along and they will say that that doesn't comply with their warranty and they will walk away from you. As far as standards are concerned, there's no standard, it's the law of the jungle. This system fails, manufacturer won't warrant it. Your waterproofer will turn around and say, you told me the level to finish the membrane, you told me to finish it below the level of the tiles. He'll do an exit stage left, the manufacturer will do an exit stage right, and you will be left holding the bag. Don't do it. If you have an architect that says, I don't want to see the membrane coming above the level of the tiles on the balcony, say, fine, there's a credit for the tiles, there's a credit for the membrane, I'll finish it up to that level and you can do it afterwards. Take a photo, document everything and leave the job. Don't do it. Because this is what happens. Block of flats in Caringbah, probably $600,000 worth of rectification work. What happens here, there's the surface level of the tiles. Water soaks into the masonry here, comes down below the membrane and causes it to delaminate. This was leaking into the unit directly below. And, you know, you stand there and say, the architect told me to build it that way. It just doesn't wash. This is an issue with bitumen bleed. You've got to be careful with your membrane selection. What I'm doing now is just going through balcony issues, common balcony issues. Bitumen bleed is a big issue. You've got to be careful with your membrane selection. With bitumen, what happens is the water will hit the surface of the tiles, soak into the grout, go down, hit the membrane, pick up the bitumen oils that's in the membrane, sun beats down on the balcony, pulls the moisture up to the surface, and out comes the bitumen. This is a block of flats in Greenwich, and this lady had white carpet and she was complaining that this black stuff was getting walked over the carpet. And the reason for that was the bitumen was bleeding up through the membrane. So when you're selecting your membrane, if you're putting it in anywhere where there's likely to be moisture, you wouldn't want to use a bitumen-based membrane system. Happy to use it in a planter box where you've got non-aggressive roots, but certainly not under balcony tiles, and definitely not under white Carrara marble, unless you want it to turn brown. And you laugh, but I've done a litigation on that. Step downs in balconies are really important to get them right. And I quite often see examples where it's not done right, and this is one that I had to inspect. This is the outside of that balcony, and you can see here that there's the surface of the tile, there's the top of the slab step here. If I go back to this slide, to compound the issue, he got the slab step position wrong. That's the edge of the slab here, going along here. And you can see he's got a long throw piece of like strapping to hold the window in place. And then what he did was he grouted up underneath the window with some cement. So what was happening was the tile bed became saturated out here. It wicked straight underneath the window sill and moistened all the carpet on the inside. To assist you, there's another one that I saw down in Maroubra, exactly the same scenario. You can see that the tiles finish above the top of the slab step. Moisture, you know, it's funny, water flows downhill, it doesn't flow uphill, right? Water's on the surface of the threshold tile, slab steps down there, what's going to happen? You know, it's like a sewer pipe, you know, poo flows downhill. This is a sectional detail from the Red Book in the MBA, just to assist you with how it should be detailed. You can see this is a exposed, we broke balcony step downs into two different methods of detailing. One is an exposed location and one is a sheltered location. For example, if you had a ground floor sliding door going out onto a balcony that had a 3 metre overhang that faced due north, you wouldn't waterproof that the same way as top floor of the AMP building facing south, right? So you really got to look at your door and the level of exposure and consider how it's to be detailed. So this is an exposed location balcony. You can see the membrane goes up over the slab step, turns up at the back of the frame, so that your effective step down is from this point here, which is your top of your membrane, down to the surface of the tiles, and it's 100 millimetres minimum step. Your overflow pipe is 50 millimetres below the top of the membrane. That means that you can get 50 millimetres ahead of water over the whole of the balcony, over the top of your overflow before it's going to come in. So this is a standard detail. Now the beauty of these details is that if you've got an architect saying, mate, I don't want you to do that, I want these tiles up at this level up here, which is usually what they want, the architects, and I apologise if there's any architects. In actual fact, no, I don't. If the tiles are up at this level up here, you can take this detail and say, mate, I'm sorry, but this is a recommended method of detailing a step down, and that's the way I'm going to do it. If you don't like it, I'm quite happy to install a door, and you can waterproof the slab step and I'll walk away from it, and you can do the tiling later on. Alternatively, sheltered location door, you can see the membrane turns up here and you've got the alcohol flashing underneath it, which is an alternative detail. Terminations are really important with membrane systems, and quite often I see polyurethane membranes as per that last slide that showed it delaminating. Most people don't realise, but all membranes need to have some form of termination, whether it's a membrane overflashing or a pressure seal. And quite often what I see is just painted on membrane finishes, you know, at tile level or above tile level, water gets behind it and delaminates it. So there's standard detailing in the book, which you guys have probably all seen. This poor fellow here had no idea what was going on, and you can see there's a pressure seal, there's the top of his membrane. You can see the way it's detailed straight across the movement joint. You know, it's like, help, what do I do? You know, and if you're the builder warranting that for 7 to 10 years, it's your bum on the line, not his. I would just clarify, these are standard flashing details. We've deleted this out of the book because I don't agree with it. Well, the committee, we debated it after I inserted this in the document. You'll see in the new book, a standard cross-cavity flashing comes out. This is not filled with mortar. Two different alternatives. Membrane turns up here, cross-cavity flashing. Alternative 2, membrane comes up here and flashing comes out over. I don't particularly like that detail, wouldn't recommend it, because what you're doing is putting moisture in the cavity, and you can end up with humidity problems. And I would, if I was going to do that detailing, I would take this membrane right to the top. But if you're going to do that, very important that the substrate has fall. Cross-cavity flashings have to come out to the outside face of the wall. It's a requirement of the Australian standard that all flashings finish at least flush with the face of the brickwork. And I often see this detail. What I say to my builders, that I project manage a lot of building work, I say to all the builders, look, leave the flashing sticking out of the wall 40 to 50 millimetres in every situation, regardless of where it is. Because it's really easy later on to come along with a Stanley knife and just run the Stanley knife along it. You only got to slightly score it and then you can literally get it and it rips off beautifully. Right? But to come back later on and try and join onto that flashing, if you need to use it as an over flashing, is a very difficult thing to do. If you ask me, I think all flashings, regardless of location, should come out and turn down the face of the wall. Very difficult with rendered walls, but you know, if you could sneak that into all your building design, because you think about it, say you've got a junction of a ground floor and a first floor extension. If you bring the flashing out and you finish it like as detailed in this shot here, with it behind the render, as the water comes across the flashing, it blows the paint off the face of the wall. Is that a defect? Yes. Would you get in trouble for it? Yes. Would you have to fix it? Yes. So, you know, you need to start, you know, if I were you guys, I'd probably come up with standard flashing details, standard waterproofing details, and implement them on all your jobs. Give it to the brickie, give it to the renderer, and try and implement as much standardisation of your waterproofing flashing details as you can, because by far the biggest risk you've got is moisture in building. People will put up with a door that might be binding, you know, or they might put up with a nick and a bump and maybe some poorly finished timber, but there's no sense of humour when it comes to moisture penetration. This is a door on a block of flats that I inspected. You can see the cross cavity flashing finishes here and doesn't run up to the back of the frame. Theoretically, this flashing should come through, turn up as a boxing, and it should be sealed to the subsill flashing under the window. Products that you can use to seal flashings. You know, quite often I see, I pull the flashings apart and there's no sealant between the flashing, or there's silicone in there. There's only there's 3 products that are readily, I wouldn't even say they're readily available, but there's 3 products available on the market that you can use to join flashings. Write them down. They're Tremco Polyroof, and I'm not here pushing any products. Write them down, guys, for God's sake. Tremco Polyroof, Sika Black, and Ormanoid Bitumen Paste. Tremco Polyroof. Right? The beauty of Tremco Polyroof is you can get it in the big long sausages. Sika Black and Ormanoid. The problem is with Ormanoid, it comes in a tin and it's really messy to work with. You've got to trowel it on. Probably my preference out of all of those would be Tremco Polyroof, because it comes in a big long sausage gun. So you guys on site, bricklayers, put a tube of that on the scaffold and say to the guys, look, any lap in any flashing, don't care where it is, if I don't see this stuff squeezing out the end, you're pulling the bricks out and you're doing it again. How much is that going to cost you for a job? Maybe $50. How much will it save you? Thousands. Every job, bricklayers, drop that on the scaffold. I guarantee you at some point in time, especially where you're doing first floor additions in timber frame buildings, where you've got that cross cavity flashing, it'll save you bacon, guarantee 100%. The other thing too is to water test your flashings in timber frame buildings. Once you've got you know, before you line the inside, you've got that cross cavity flashing at first floor level, go around, clean it out and stick a hose in there and flood it. You know, how easy is it before you put the lining boards on to go around with that tube of Sika Black or Tremco Polyroof and patch up a flashing. But once you've got the lining boards on, I guarantee you they'll have moved in and they'll have their furniture, their brand new plasma TV, it'll blow from the south or the west and it'll leak. So easy during construction. Every flashing, water test it, stick a hose in there, give it heaps. It's really simple test and it'll save you money. These details are straight out of the Master Builder's Red Book. You can see the membrane turning up on the slab step, and you can see that there's a connection between the stop end in the subsill and the cross cavity flashing. If you guys have to anchor a subsill like this is a typical subsill. Say you've got like a 4 metre long window and you've got to anchor it through the membrane. Normal building practice that I see, waterproofer might go through and paint the slab step and not even do a turn up. In other words, they'll paint the top of the slab step and not provide a turn up. Well, that's a waste of time as far as I'm concerned. Even if you put a 15 by 15 angle at the back, at least that'll do something. Carpet's 15 millimetres high. The angle will be below the level of the carpet. So put an angle in. Next thing I'll quite often see is the waterproofing will be through there, and then the aluminium door guy will come through who doesn't give a rat's about waterproofing. He'll just literally drill straight through the membrane. He'll put his Dynabolt in if you're lucky, or his knock-in pin in. Membrane's hole, subsill's got a hole in it, and he'll smear silicone over the top of it and tell you that it's sealed. And you'll say, mate, did you seal the subsill? Yeah, mate, sealed the subsill. Beautiful, yeah, it's all done. First time you get a southerly or a big westerly, you're going to have a leak. Yep, I see it all the time. You know, this isn't rocket science, you know, but we've been here for 200 years and we still can't waterproof a bloody opening. So what can you guys do to detail that? What I would do is I would waterproof it with the waterproofing going up over the slab step, and in all my aluminium windows, I don't care where it is, how easy it is to have a bucket of black stuff on the job. Put an angle in and do it yourself. Go and learn how to apply a little bit of membrane, right? It's not really that hard. I would waterproof the slab step like that. Then what I'd do is come along and drill straight through it and put your studs in. I'd normally use stainless steel Chemsets. Chemset the stainless steel rods in. If you wanted to save a few bucks, use Booker rod, right? Use a Ramset epoxy those in. Let the epoxy go off, come back, clean around the stud with some solvent, and then re-detail the membrane up onto the stud, right? Aluminium door guy comes along, he'll see the stud sticking up out of the slab step. All he has to do is put the subsill over the top, mark the underside, drill polyurethane around it and bed his subsill on top of the stud and then seal over it. And that'll work. If you've got a sheet membrane, you can do exactly the same, whether it's Torchon or PVC. It will work. I've done it. I've done it on the top floor of the AMP building with a PVC membrane, literally. I've done that detail there. Planter boxes. There's nothing out there. There's no protection for you guys at all at the moment with planter boxes. I see planter boxes as probably the biggest area of litigation probably in the next 10 years. It's fantastic. It's keeping me in work. And the reason for that is a reliance on liquid membrane systems. Probably 90% of the membrane failures in planter boxes that I look at are all polyurethane membranes used in planter boxes. Why? Because polyurethane membranes are not root resistant. In other words, roots will go straight through them. Okay? You've got 1.2 millimetres, if you're lucky, of membrane film thickness. On the other side of that, you've got a really nice moist brick. Roots come along, plants haven't been watered for 3 months. On the other side of that 1.2 millimetres, if you're lucky, and quite often it's down to 500 micron, is a nice moist brick. And between that is between the root and that nice moist brick is a very thin membrane system. Roots will just go straight through it. Guarantee you 100%. The only membranes that will not allow the root to go through are the ones that are designed for use in planter boxes. There's only 2 types, and if you want to write them down, it's anti-root torch applied bitumen membrane, so it's anti-root, or they call it garden variety. The other membrane system is a sheet PVC, and there's various ones of those. None of the self-stick membrane systems, like, I won't mention them, but you've seen the ones, they're called peel and sticks. You pull the tape off and they stick them on. The reason for that is that when they're applying those, if you've ever looked at them, it's very hard to get the glue, the lap joint, perfectly straight so that there's no flutes in it. It's like getting a bit of duct tape, and you stretch it out, and before you put it down, it sticks together. Well, it creates flutes, and what happens is the water sits in the flutes, and then the roots come along and go, you beauty, straight into that. So garden variety, torch-on or sheet PVC. Polyurethanes, no. Acrylics, no. They don't work. In America, there's a test for membrane systems in planter boxes. They call it a Shaw A hardness. And in that test, in their standard, they say that no membrane with a Shaw A hardness of less than 40% is permissible for use in a planter box. Okay, polyurethanes, I should say 80%, my apologies, it's 80%. Polyurethane membranes have got a Shaw A of 40, so it's half, and that's why the roots go straight through them. Typical planter box design, we're working on this at the moment at the MBA in our committee. This is a typical planter box design where you've got the membrane. Generally, I get that membrane to come up as high as possible in the planter box. I generally have a drainage cell in the base. Over the top of the drainage system, you need direct rotting access, so if roots do go down there, you can clear it out, and an overflow. My preference for an overflow is that the overflow really should be separate to the primary drainage system, because the weather we're having at the moment, if that's connected, which it will be, to the main drainage riser inside the building, if you get 200 millimetres of rain, what's going to happen? That'll become fully charged. Water will just build up in this pipe. This will become 100% saturated and the water will overflow. The other design consideration that we've got in our MBA book is that this outside wall of the planter box should be kept at least 20 millimetres below the inside wall, so that if this ever fills up, it'll overflow that way, not this way onto the balcony. You won't even notice the 20 mil, but I tell you what, when that water's filling up in the planter box and it goes down the outside of the building, you'd be quite happy about it. This is another detail where a planter box is up against a building, and you can see the cross cavity flashing in this situation. This should be a 9-inch wall. I don't agree with this, please ignore that. This creates a slip plane, so I apologise for that. We're still developing all these details. Services in planter boxes, don't bring them up through the floor of the planter box. All services should come in through the top level of the planter box. The only penetration you want in the bottom of a planter box is the outlet, the drainage outlet. You know what I mean? It's like you wouldn't jump into a boat and then go and drill a whole bunch of holes in the boat and think, geez, how lucky am I? You know, the less number of holes in the boat, the less risk, of the thing sinking. Same with planter boxes. And this is what happens with planter boxes when they fail. You can see this water under a planter box. That's a planter box membrane that's been too thin and the roots have gone straight through it. Another planter box that's failed, no fillet joints here. You can see the surfaces have been painted into the membrane system. You should never do that. They should be recessed into the wall of the planter box. Roots going straight through, you can see the root going through the membrane here and over here. And there's a membrane that's too thin in a planter box. You can see the roots have attached itself to the planter box and coming through the back of the membrane. Roofs, basically you've got the standard BCA requirements for flashings. This is straight out of the BCA. If you're not getting a BCA every year and keeping it in your car, well, you should be, because that's a really good reference document. These are straight out of the balcony book, but you can use these for roofs. You can see that this is a typical capping detail with side fixings. This is a concealed fixing detail. You can see that the membrane, the capping just clips over and comes straight over. So you can use those. These similarly are straight out of the balcony book, but you can use that for a roof detail. And they're movement joint details. Once again, membrane details straight out of the Red Book on how to terminate roofs. This was one that I looked at over, there were 3 buildings. Literally, this was the size of 2 football fields, and there were 3 of them. Membrane looked like the moon. These were moisture blisters under the membrane. I said to the builder, I said, mate, what did you do wrong? He said, you know what? He said the applicator told me he didn't want to do it because the roof was too wet. It had rained for 2 weeks before. We had liquidated and ascertained damages clause against us. We thought that it was better just to get the roof membrane on, and we would worry about the liquidated, because the liquidated ascertained damages was too high. We just thought, well, it's cheaper for us to come back and fix it later on. Well, they're still fixing it, and thousands and thousands of dollars. That's what it looks like when you step on it, because I did. This is another one that I looked at, same situation, but it shows what happens. You can see that all you can do is grind the membrane, patch it, and then what happens is the moisture just comes up alongside it. You can see that it's coming up alongside there. This generally occurs with acrylic membranes, cementitious acrylics and standard acrylics. So doing moisture tests before you put the membrane down is important. Torch-on membranes, you can see here the granules on the torch-on go underneath the membrane, and there's no bitumen bleed coming out through the edge of the membrane. This is a bitumen membrane with silicon. Silicon's solvent-based, bitumen is an oil-based, so what happens when you put silicon and bitumen together, they don't like each other, they don't stick. No turn-up. This is a house in Bellevue Hill. No turn-up here. Shocking job. Same job in Bellevue Hill. Torch-on membrane on the roof, turns up on the face of the windows. Look at the water underneath here. I reckon the cost of repair on this will probably be in the $400,000 range. And this is just an ordinary home builder that's got this one. And that's it, guys. I'm sorry it was sort of so late. In terms, if I could say anything, if you walk from this room and you remember it, if you could remember 2 things only. Movement kills membranes, right? Look for movement. The other thing I would strongly suggest is that if inside here tells you it's wrong, and up here is telling you, well, I might get away with it, listen to what's in here, because it'll probably come true. Don't do it, walk away from it. It's probably the best advice you could get. Any questions?